This is section 3.1. We're going to talk about reference angles. A lot of you are going to feel like this is, I'm not going to necessarily say redundant, but it's kind of similar to what we have done before. Okay, but now we're going to actually attach what we call a reference angle. When I talk about reference angle, I'm going to denote it as theta hat. And those of you that have had statistics, you understand what I mean. If you have not, and you're like, oh my goodness, what is he talking about, this hat? The theta looks like it has a hat on top. It's that little emblem on top. So I'm just going to call it theta hat from here on out. That's what we're going to call our reference angle. Okay? For anything in the first quadrant, this is pretty straightforward. It's just the angle that's there. So how do I graph a 30-degree angle? It's just 30 degrees up. Where these reference angles come into play is now, beyond this, is how do I graph a 135-degree angle? Well, that's 90 degrees, and then we have 45 degrees more. Here's my actual terminal side. This is 135 degrees in here, but what I call our reference angle is always going to be, we're going to make a right angle down to our x-axis, which we have done that before. The angle inside that we talk about is called our theta hat, or our reference angle. So in this case, my reference angle, which I will denote it as theta hat, is going to be a 45-degree angle, because if I go 135 degrees, I need a 45-degree angle to get myself all the way to 180. That's what we do in quadrant 2. Quadrant 3, so 240 degrees. I don't know if you can see this on your paper or not. 180 is straight. I need to go 60 degrees past that. So there becomes my terminal side. Now to make my reference angle, I still want to make a right angle with my x-axis. So the angle closest to the origin in between the terminal side and the x-axis becomes my reference angle, or my theta hat. And what measurement is this? 180 plus what gets me to 270? 60 degrees. So I have a 60-degree reference angle. And then the one in the fourth quadrant, so 330 degrees, I am 90, 180, 270. I need to go, what, 60 degrees farther here. The problem is, I want to make my right angle with the x-axis. So there's my right angle. My theta hat, or reference angle, is going to be in the middle, or in between the terminal side and the x-axis. So what degree measure do I have that I need to get all the way back to be a complete full circle? My reference angle will end up being 30 degrees to get myself back to being a full 360-degree circle. So that's what the kind of picture looks like for any first quadrant. Second quadrant, you will subtract from 180. Third quadrant, figure out what you need to add past 180. Fourth quadrant, I can subtract from 360 and figure out my reference angles. Okay? This is what I kind of just talked about. In general, to find it, first quadrant, it's its own reference angle. You subtract from 180, subtract 180 from the angle, subtract the angle from 360, or you can just kind of use logic to where you're pictured at. What we need to recall from things that I've done before, the all students take calculus part, we need to know what and where these trig functions are positive, negative, or whatever. So all students take calculus. Just know that all of them are positive in quadrant 1. The sine only is positive in quadrant 2. Tangent's the positive one in quadrant 3. Cosine's the positive one in quadrant 4. This is going to help us set these up. Now this slide, you're going to maybe be like, hey, I've done this before. I can do this. Okay? So I want to find the exact value. Now a lot of times what we'll end up is these special triangles. So cosine of 300. Can you graph 300 degrees? Most of us should be like, yeah, I can do that. That's not too hard. 270, 300 would be. This is 30 degrees in here. The problem is I want my reference angle. That's what I'm referring to. Okay, to find the exact value, I'm going to use my reference angle. So my theta hat is inside here. Now this is 300 degrees from start to my terminal side. I don't want any of that. I want what my reference angle is. So my reference angle, or my theta hat, turns into being a 60-degree angle. And if that's a 60-degree angle, we should be like, hey, that's 1, 2, square root of 3. Now a lot of this is going to be redundant. We're like, sweet, the square root of 3's here, the 1's here, the 2's here. What I talked about with the all students take calculus, I'm asking for cosine. Should cosine be positive or negative in this quadrant? Okay? Oh, I'm jumping ahead. Cosine means, hey, this should be positive here. So my answer should be positive. Another way to not worry about the all students take calc would be which ones of these sides should be negative to start with. Now, a 1 is to the right, that should stay positive. Square root of 3 is down, that needs to be negative. And your 2, your radius, will always, always, always be positive. And then you can look, okay, what's cosine? Adjacent hypotenuse, or you can think about it as your x over your r. So the cosine of 300 degrees is simply just 1/2. Okay? So that's kind of the process. So this isn't a lot different than what we have done before. It's just you're using the term called this reference angle. So 135 is halfway in the second quadrant. I'm going to start building these triangles quickly. My reference angle, theta hat, is going to be 45 degrees because 135 subtracted from 180 is 45. So I know it's going to be a 1 square root of 2. And then which ones of these need to be negative or positive? I know that this bottom one is left. That needs to be negative. Up is positive. Okay? Sine should be positive in this quadrant because I'm going up. Opposite is 1. So I'm going to write sine 135 is 1 over square root of 2. But I can't have 1 over square root of 2. I can't do that. I have to do the rational thing. So it's root 2 over 2. Okay? Tangent of 210. 210 degrees, that's 30 degrees beyond 180. Alright, so my reference angle now becomes 30 degrees. I know this in here is a 30, so I know that's a 1. This makes root 3 be this one. What needs to be negative here? I am both left and down. Hypotenuse is going to be positive 2. Okay, and now if I want to do my tangent, I need to do tangent 210. Alright, and that's going to be your opposite, which is negative 1 over negative root 3. Negative 1 over negative root 3. Two negatives make a positive, which tangent all students take calc. I should be positive there because two negatives make a positive, but I got to multiply our top and bottom by square root of 3 over square root of 3. So I end up getting root 3 over 3, and it's positive. Alright? Then the last one, cosecant of 120. So 120 puts me just 30 degrees beyond. I'm going to make my right angle. This time my reference angle, my theta hat, will be 60 degrees. Because I need to add 60 more to get all the way down to 180. So that puts the square root of 3 here, a 1 here, 2 there. This is negative. What is cosecant though? Okay, sine is y over r, so cosecant would be the same as r over y. My r value is what? 2 over my y value is root 3. I got to do root 3 over root 3. So I end up getting 2 root 3 over square root of 3 times the square root of 3 is 3. So that's how I would go about graphing these, giving yourself a picture, and then finding that reference angle. So now we're just giving that special angle a particular name, so that we can help do this. Now, this should be semi-review, I hope. And that's going to lead us into this problem right here. So our problem here says find the value if sine theta equals negative whatever the number is, okay? And theta terminates in quadrant 3. So basically they're saying, okay, what angle do I get that makes this happen? Now, this isn't going to be necessarily a special triangle. What we need to do, what quadrants is sine negative? So sine is y over r. Where is y negative? And hopefully a lot of you are thinking, hey, y is negative down. So what you can do is, and this is basically how I do this, I'm going to draw two triangles. Here's my theta hat and my theta hat. Okay? I want to figure out, hey, those are the two triangles that are going to make my sine negative. The two options that I have. Now technically I only need the one in quadrant 3 because that's what they specifically ask for. But in order to find my angle, I need to solve for sine theta. I need to basically find that theta. Now if you guys find an angle, I've said this about a million times, how do I get theta? You must take an inverse. So I'm going to take sine inverse of negative 0.5592. Make sure your calculator's in degree mode, and you'll end up getting theta equals negative 34 degrees. Alright, sweet. Now, that doesn't really help me a lot though. Negative 34 degrees just tells me that I'm 34 degrees down. So I know this reference angle, my theta hat, will actually be, now this is what gets confusing, I got an answer that was negative 34. The negative tells me that I'm just going down. My reference angle is actually positive 34 degrees. So I hope we can all make that connection that, hey, the reference angle is always going to be positive. It's just that the answer that you give right here from the calculator just tells you what quadrant it's going to be in. So this tells me that in quadrant 4, my reference angle is 34 degrees. I want quadrant 3 though. Well, how does this all work? A reference angle is a reference angle no matter what quadrant you're in. So if I have a negative sign, there's actually a second one that gives me the exact same answer, but in the other quadrant that gives you the same sign. So I can say my reference angle is the same thing in quadrant 3. And now what is the answer actually asking us to do? I want to find the actual angle from the starting spot on your triangle. So from the positive x-axis, I'd say 90, 180, and how much more? That's where your reference angle comes into play. I can say 180 plus 34 equals the 214 degrees. If you take sine of 214 degrees, you better get that negative 0.5592 approximately. Also, you could and or should, if you start from 0 and go all the way to there, what is another possible answer? If I would say, if they said just in quadrant 4, what angle is it? It's what? 360 minus 34, so 326 degrees. If you would take sine of 326 degrees as well on your calculator, you should end up getting this answer up here in your calculator, negative 0.5592. There will always be two possible answers for this scenario. Okay? And that's where this gets like, oh my goodness, Wilson, you're killing me. It's alright, we're going to be okay. We just got to think about all the relationships that we have been told all semester so far. Okay? So here's another one. Find theta. Okay, so theta means I need to find the angle. Now in this one, I'm going to also only find it once, but I'm actually going to give you both answers. Okay? Tangent is negative. So we got to think about what quadrants is tangent negative. Now I said all students take calc. Gives you the ones that are positive. So tangent is positive in 1 and positive in 3. I want tangent to be negative. So I know that I'm looking for triangles in quadrant 2 and quadrant 4 because tangent's going to be negative. Now how do I find that reference angle? I need to find theta. So I'm just going to take tangent inverse, because remember the only way to find an angle is if you take an inverse. So if you take tangent inverse of negative 0.8541, you're going to get theta to equal negative 40.5 degrees. Now once again, just like the last problem, this negative sign is referring to putting this on the graph the first time. So that's just saying I'm going 40.5 degrees down. So my reference angle is technically a positive 40.5. Okay? The fourth quadrant answer, if I ask for the fourth quadrant, okay, which I do ask for the fourth quadrant actually, you would end up doing what? It's 360. I'm not quite all the way around though. I'm 40.5 degrees shy of getting to 360. So if you take 360 minus that 40.5, you would get 319.5 degrees. So that's the quadrant 4 terminal side answer. And technically this question only asks for the fourth quadrant one. If I would ask you for any angle, we need to think, is there another quadrant that tangent is negative? And I said yes, second quadrant. I can dump my theta hat, my reference angle, into the second quadrant as well. If I deem my reference angle to be the same, Okay, what is my new answer from start to this terminal side? Now in quadrant 2, all I'm saying is that I am 40.5 degrees short of 180. So if I say quadrant 2 answer, it's 180 minus that 40.5, you would end up getting 139.5 degrees as another possible answer for this. And you can always check this by going, okay, take tangent of 139.5. You better get this number. Take tangent of 319.5. Once again, you better get that number. So that's how we can go about doing all of that fun information. Now this is where we're going to be like, stop it, Wilson, okay? So I need that angle. Alright, same thing. I have cotangent. Well, that relates to tangent, right? But I need to take tangent inverse. So if you go back to last chapter and you think, okay, if I need to take tangent inverse, that means I need tangent theta on top. In order to find this relationship, I need to do the reciprocal of one of the sides. Well, if I'm just going to change the tangent, I need to take the reciprocal of the other side. So it's going to end up being 1 over the negative 1.6003. So to find theta, it's going to be tangent inverse of that fraction. Okay? And my angle then, when I take the tangent inverse of that fraction, I get negative 32 degrees. Okay? So how does this work? I'm going to graph this thing. Now cotangent, same as tangent, is negative. So just like the last problem, I know I'm in the fourth and the second quadrant with the same rationale that I used before. This negative 32 degrees is telling me that I'm going 32 degrees down, but in all actuality that means my theta hat is just positive 32 degrees, which likewise is just saying that in the other quadrant that is also going to make me negative, that same reference angle is going to also be 32 degrees. Now what two angles, now I'm only asking for quadrant 2, but I'm going to try branch out. What are my two angles that I could get between 0 and 360? Here are my bounds that will make this original equation true. Okay? So I need to figure this out. From start to just the quadrant 2 one, I'm now 32 degrees short of 180. So if I go, I'm going to denote it as quadrant 2. It's 180 minus 32. Okay, I end up getting 148 degrees as one of my answers. And then the quadrant 4 answer would be, I can go almost all the way around, but I'm 32 degrees shy of an entire circle. 360 minus 32, I end up getting 328 degrees as my other possible answer between 0 and 360, or in one complete circle. Alright? Now, how could you actually check this one? You're going to have to go back and figure out, okay, cotangent theta. Now I want to evaluate this one. This might throw some of you. Cotangent theta is the same as 1 over tangent theta. So if you actually go 1 over tangent of 148, you should get this negative 1.6003. Because that's the difference. I'm evaluating here. I wanted to take the inverse there. So it's going back to that relationship from chapter 2 that allows us to do that. So there is our snapshot and talk about reference angles. We will be using these literally through the rest of the year. In class tomorrow we will be working on this assignment, and I hope you all have a wonderful day.